section 4 is on nth roots. So basically we're going to be talking about radicals today. So let's go ahead and do that. So we all know what it means to raise a number to the nth power, right? So for example, if I have x to the power of n, I know what that means. The inverse of that is finding the nth root. Okay, so the inverse of raising a number to the nth power is finding the nth root. So for example, we know what this means, right? X to the power of n equals a. Basically, when you have something like this, you're like, okay, what number to the power of n equals a? Another way to write it is this: x equals nth root of a, right? Which means, okay, so okay, so let's take a look at this first one here, okay? I have x cubed is equal to 64. Basically, what that question is asking for is what number, when you multiply it by itself 3 times, is 64? Now, this is another way of writing the same thing. When I see this, this is also saying what number, when you multiply it by itself 3 times, is 64. So do you see how these two highlighted parts are different ways of writing the same exact thing, okay? So in both of these cases, what number do you multiply by itself 3 times? 4, right? So that equals a 4, okay? Because 4 times 4 times 4 is 64. Okay, same thing here. So if I was walking down the street and I saw a billboard, and on the billboard, all it said was this: x to the power of 4 equals 625. Well, I would say to myself, oh my God, somebody's looking for a number that when you multiply it by itself 4 times, you get 625. And then on another street, if I saw this on a billboard, I would say, oh my God, somebody is looking for a number that when you multiply by itself 4 times, you get 625, right? Different ways of saying the same thing. What is that number? A 5. Okay. And then here, x to the power of 5 is 32. Same as saying 5th root of 32, which is how much? 2. Okay. So let's talk about principal roots. Stein is right. So let's talk about principal roots. Some numbers have more than one nth root. What does that mean? If I were to tell you, find all the numbers that when you multiply it by itself twice, you get 81. Well, you're like, okay, 9, because 9 times 9 is 81. But also negative 9, because negative 9 and negative 9 are also 81, right? So 81, okay, has 2 square roots, because both 9 and negative 9 squared will be 81. However, when there is more than one real root, okay, and n is an even number, the principal root is the one that is not negative. So here, yes, 81 has 2 square roots, but the principal root of 81 is just the 9, not the negative 9. That's why when somebody tells you, hey, what is the square root of 81? You don't say negative 9. Most of the time you just say 9, correct? That's the principal root. That's what we're going to stick with in this lesson. Even though the book sometimes does plus or minus, they're not right, okay? We're not going to do that, okay? So, yes?
So on like a test, you're not going to ask us to do like plus or minus?
No, if I were to say, simplify the square root of 81, you just say 9. But if I had x squared equals 9, and you took the square root of both sides, then you have to say plus or minus 3, okay? But if I just said, what is the square root of 9, you say 3. Do you see the difference in those two scenarios? Okay? All right. So, okay, a little bit of vocabulary, right? For when you're on Jeopardy, right? When you have this number here is called the index, Okay, that's just called an index. If it's a square root, there's nothing there. It's an imaginary 2. Otherwise, it's a different number. And then that symbol is the radical. Technically, that's not the root. It's the radical. And then this number inside is the radicaned. Okay, radicaned. Okay, so let's simplify this. The square root of -8. Okay, we know this from last chapter. What is it? 2i root 2. Okay, good. Cube root of -27, how much is that? -3. What number, when you multiply by itself 3 times, do you get -27, right? Well, -3, -3, -3, -27. So notice both of these radicands were negative. In this case, the index, the 2, was even. So I had to have an I. In this case, the radicand is negative, but this index is odd. It's an odd root. So the negative is okay. All right? That was your question, wasn't it? Yeah. Okay, so here, take a look at this. There's already a plus or minus in front of it. Okay, so we're going to keep the plus or minus. And I have a root 16x to the 4. You apply the root to each of these separately. So root 16 is 4. And then what about root x to the 4? X squared, because again, you're looking for what multiplies by itself to give you x to the 4, and it's x squared times x squared. Okay, here I have a negative out front. I have the square root of something to the power of 16. So it's going to be y plus 7 to the power of how much? 8. 8. So what you're going to do is you're going to take this number 16, and what number is in here? 2. Divide them by each other. So that gives you negative y plus 7 to the power of 8. Okay, that's a square root, so there is an imaginary 2 in there. Okay? Okay, so now take a look. Look here. If you have something to the power of 8 times something to the power of 8, you do get an exponent of 16, right? So, yeah. Okay. Yes, you could have done the same thing for C. 4 divided by 2 is 2. Okay? You leave it like that. That's it. We're done. Okay? Okay. So, we have a radical. Okay, so, can you... I get nervous. I know. Okay, so if you have a radicand, okay, so we have x inside, okay, that's the radicand. Okay, suppose x is positive, all right, both of these, x is positive, like this is root, I don't know, 9, 12, whatever. Now, if this is even index, then we get a positive real number. All right? If this is even, I get a positive real number. So for example, if I have, the square root of 16, that's 4. If this is odd and I have a positive inside, I also get a positive real number. So for example, if I have the cube root of 8, that's 2. Okay, now let's think about what if this x is negative. Okay, now if I have an even root, then I have to get an imaginary number, because if I have the square root of some negative number, then this is 4i. Okay, that's an imaginary number. But if I have the odd root of some negative number, then that's just a negative number. Okay? All right? So if radicand is positive, then, really there isn't an issue. But if the radical is negative, if I have an even root, it's imaginary. If I have an odd root, it's just a negative number. And then if the radicand is 0, the roots are always 0. Okay. This you guys already knew. There's really not any new information there. But let's talk about when to use an absolute value. Okay, let me ask you this question. Suppose you have the square root of some number, 16. Okay, or the square root of just anything. Is it possible that whatever comes out of this is negative? No. Whatever comes out of a square root must always be positive. It's the same if this was a 4th root or a 6th root or an 8th root or a whatever root, right? So suppose you take the 4th root of something and you get 7. Okay, I have no issues there. Suppose I take the 4th root of something and I get x. Now I might have an issue, because if x is 4, then fine. But what if x was a negative number? That can't happen. I can't have a number come out of a 4th root and be negative, correct? So then, here is the rule. When you have an even root of an even power and the result is odd, you must use absolute value. In short, here is what you say. If you have even, odd, you have to use an absolute value. Okay, even, odd. Just remember even, odd. So let's take a look at this for a minute. This is the same as the square root of 75 times the square root of t to the 6. Okay, we know what to do with the square root of 75. This is 5 times 25, which is 5 times 5. I'm sorry, it's 3 times 25. Okay, so this is 5 root 3 times. What about this? It's t to the what? It's t to the 3. But now you have to put it in absolute value, because if t's value was a negative number, if t was negative 2, then this would be negative 8. But how can it be negative 8 if it came out of a root, right? If it came out of a square root. So I have to put absolute values around it. Okay, and that will be the answer. Okay, let me do a couple more examples and then I'll take questions. So take a look at this next one. This is the square root of negative 36 times the square root of y to the 4. Okay, you don't have to split them up like this every time. I'm just doing it for the first few of them, just so we get used to this. Okay, root negative 36, I know is 6i. What about the next one? Y squared. Do I need absolute values there? No, because no matter what, that's going to be positive. Okay? It's even. It's an even exponent because it's even. Okay? Let's take a look at this next one. I have a negative outside. What happens to the root 49? 7. How about the u? 4. And the v? 6. All good. We're done. Let's take a look at the next one. Cube root of negative 27 is what? Negative 3. X to the what? 2. Y to the 4. Good. Okay. How about this? Ooh, 5th root of 243. So I got to split up this 243. I can do 3 and 81. 9 and 9, 3 and 3, 3 and 3. Okay, if I have a 5th root here, then I have to group these by 5. Okay, well, let's see. 1, 2, 3, 4, 5. That's all one group of 3s. So 1, 3 comes out. And then what about the x plus 2 to the 15? X plus 2 to the power of 3. Okay? this exponent divided by the 5. 15 divided by 5 is 3. Because it's a fifth root. So you have all those threes. Each group of 5, you have to group them by 5. Each group of 5 comes out as a single 3. Okay? Here, fourth root of 16. What is that? 2. X to the what? 1. Y to the 2. Z to the 3. Okay, now you have to divide everything by 4. Now you have even, odd. So for some of them, so which one gets an absolute value? The X and the Z. So I can combine this and I can say 2y squared and in absolute value xz cubed. No, combine them. Okay, questions, Ariel. Whenever this highlighted 4, whenever that's even, and this exponent is even, and I do 4 divided by 4, and I get x to the 1, that's odd, that's even, odd. Even, odd. What? No, the 6, we're talking about exponents. Just exponents, yes.
My question was for A.
Okay. All right. So here, all right, so go ahead and take out your calculators now. Okay. Let me just clear this. Okay, so let's go ahead and do some of these. If we want to do an nth root, you guys know where the button is? I'll show you. Yeah. So I want to do the cube root of 58. Press Control. Cube root is 2 rows down. Right here, it's nth root. So you see the cursor is outside in the index. So 3, and then I press you can either press tab or the right arrow button for 58. Enter, and that's 3.87 and so on, right? So it says to approximate to 3 decimal places. So we're going to say this is approximately equal to 3.871. Okay? Questions? Yeah.
Doesn't say that. It says like 58 minutes. I think you did it wrong.
Okay, so I'll be over in a minute. Okay. In the meantime, I'm going to give you like half a minute to do the rest of these for me, please. B, C, and D. What do we get for these? Negative
8.718.
Okay, and this one?
Negative 2.122.
And 2.903. Okay, so, all right. Okay, so
We have to write like the approximate.
you don't have to. Okay. So according to a worldwide injury prevention study, the number of collisions between bicycles and automobiles increased as the number of bicycles per intersection increased, right? That makes sense. The relationship can be expressed using this equation, where B is the number of bicycles and C is the number of collisions. So notice I read all this, obviously, to give me an idea, and then you have to go and you have to highlight or underline things that are relevant to you. And definitely, you always need to know which equations you're working with and sort through the equations. And then you always need to know how to define your variables. Now, can everybody stop writing for a minute because I have something important to say. this is a very, very basic, very simple question that pretty much might be insulting to some of you, like insulting your intelligence, some of you, right? The point of this is, yes, it's really that simple. And some of you could just be able to plug this into your calculator and just get the answer like that. But is it ever about the answer, really? No. It's always about the process and the work and justifying your answer, right? So this question is saying, estimate the number of collisions. So we want C at an intersection that has 1,000 bicycle riders. So B is 1,000. Okay. So we know that it's C equals fifth root of 1,000 squared. Okay, yes, that's a very simple thing to write down, but it's not beneath you to show some work. So you have to write it down to justify where your answer came from. Okay? So this is how much when you plug it in. But what is it exactly? 15.84. Exactly, 15.84. So it's about 16 collisions. Always round correctly. Don't just automatically round up, right? So if this was 15.3, we would say 15, not 16. Okay, next. If the total number of collisions reported in a week is 21, so now if C is 21, estimate the number of bicycle riders that passed through the intersection. Okay, so now 21 is equal to the fifth root of B squared. And so here, what are we going to do? Raise both to the power of what? 5, because the index is 5. So we raise it to the same power as the index. So now I have 21 to the power of 5 equal to B squared. What do I do now? Take the square root of both sides. So B now, technically B should be plus or minus. But do we care about the minus in this case? No. So this is going to be the square root of, right? Please plug it in one shot. The square root of 21 to the power of 5. And that's that number. 2020.92. So it's how many bicycle riders? 2021 riders. Okay? All right. So now we're done with the lesson.